Alright, today we'll be showing you some techniques to evaluate limits, and our first example will be direct substitution.
Alright, here we go.
Alright, so if we had a problem limit as x approaches 2 of 10 over x minus 3, to find the limit of this one's fairly simple, so you just plug in 2 for x. So you get that, and then your answer ends up being -10. Alright.
Very simple.
Okay, now for our second example, we're going to show you what happens if you get the indeterminate form and how to solve it with factoring and simplification. The indeterminate form is when it ends up being 0 over 0, so it doesn't really tell you anything, so that's why I need to fix it. Alright, so our problem for this one is going to be limit as x approaches 7 of x squared plus, minus 5x minus 14 over x minus 7. Okay, so we are going to, if we plug in 7, you end up getting 0 over 0. So that doesn't tell us anything. So we're going to need to factor the top, and hopefully it'll cancel out with this x minus 7 at the bottom. And it does, luckily. Alright, so now we just, we have limit as x approaches 7 of 7 plus 2, which equals 9. I'll circle that answer too. Alright. Now for our third example, we are going to show you what happens if you get some number, not 0, over 0. So, alright. Limit as x approaches 3 of root x minus 3 over x minus 3. Alright, so if you plug in 3 for there, you're going to get 1 over, or excuse me, you have to simplify this. So it ends up being x minus 3 to the -1/2. So if you plug in 3 to there, you're going to end up getting 1 over 0. So, and that's not indeterminate, so that means you don't have an answer. So the limit is either infinity or -infinity, and to figure that out, you have to use one-sided limits. So limit as x approaches 3 from the left, 1 over root x minus 3, and limit as x approaches 3 from the right of 1 over root x minus 3. This one's not going to give you an answer because it's going to be over a negative number, and this negative here goes with that 3 because it's a left-sided limit. So this is going to give you a negative number under the radical, so that doesn't exist. But if you plug in 3 over here, you're going to get 1 over 0, so it's a positive because it's approaching from the right, so you get 1 over some positive number. So that basically means that the function's going like that, and therefore the limit is infinity. Alright, now for our fourth example, I'm going to need to find another piece of paper really quick.
Is there a pause button?
No.
Alright, well all of this is in the video then.
That's okay. Alright, so now, for our fourth example, we're going to show you what happens if you need to rationalize the function. Why are you pointing everywhere?
I don't know.
Okay. So, 4. Limit as t approaches 4. Why did I do t? Whatever. Alright. T over 3t minus 4. Alright, 4 minus t. Okay, so we're going to need to multiply this by t plus root 3t minus 4, which is the opposite of this. Alright, so this ends up becoming t squared minus 3t minus 4 over 4 minus t times t plus root 3t plus 4. Cool. Alright, so now we're going to need to factor the top, which is t minus 4 over t plus 1 over 4 minus t times t plus root 3t plus 4. Alright, now we're going to have to cancel these out here. So it's going to be t minus 4 t plus 1 over negative t minus 4. I factored out a negative from this term right here. Alright, so we can cancel those out. And now we can just plug in the 4 from the beginning. So we're going to have 5 over, wait a second, something's fishy. Oh yeah, okay, 5 over negative 4 plus root 12 plus 4, so that's going to equal 5 over negative 4 plus 4. Wait a second. Yeah. Oh, the negative's on the top. Alright, so 4 plus 4 is negative 5 over 8. Alright, there you go. Hopefully you don't make a stupid mistake there at the end like I did.
Good job.